Yes, during the last outage, we did some vibration measurements on the reactor containment wall during the testing of the safety relief valve. This work has been done in cooperation with SKF, which has helped us performing the vibration measurements, and also Westinghouse has been involved, helping us with comparing the results with earlier measurements from Forsmark 1 done in the 70s, and also to compare with analysis results from the load calculation on Oskarshamn 3. This tests has been done when we go down with the station, and also when we went up with the station after the outage. So these are not any additional tests that we has performed. It's just that we have, during the test, we have put in the vibration sensors in order to the vibration. Yep. The purpose of these measurements was to measure the vibration response in structure during the SRV actuation and compare with calculations. This project was done in our LTO project, where we are supposed to see that we have that we can cope with the loads during the lifetime, and one part of that is looking into the fatigue calculations, and one part of that is also the SRV actuations, which are included in some of the loads. So therefore, we thought it would be interesting to do measurements on the actual vibration response and compare it to the load calculations that we now use for the fatigue analysis as one input. As I mentioned, the measurements were done at 2 occasions. First, at 100% reactor power, at site 69 bars pressure during the power decrease before the outage last year, and the second measurement were done during the power increase after the outage at reactor power 5% at 60 bar pressure. The equipment that was used was a recording unit from SKF. As sensors, we use 3-axis accelerometers, and as a software, we use an SKF observer system, an analysis and reporting system from SKF. So that was the equipment we used during the measurement. On the next slide here, we can see the placement of the sensors. To the left, we have a cut-through of the reactor containment. So we see that in the bottom right corner, we have a small room where we was able to put in our vibration equipment. We have one measuring point which was put on a mounting plate. In that room, there were 4 mounting plates close to the ceiling, and we used one of them in order to put one triax. And we also put in 2 more sensors, one at a penetration, and the third on a hatch, all in the same room. To the right, you can see the placement of the 16 valves. So you can see in the bottom right corner, you can see that the measuring point is in between of VD1 and VD3, those 2 safety relief valves. So in total, there are 16 valves, and during the test, one are measuring the response time for each valve. So one valve is tested at times. So we do the measurements. We have done 16 separate measurements when we went down with the station, and 16 measurements when we went up with the station. So in total, 32 measurements were performed. And here is some photo of the installation. Here is the measuring point number 1, which are mainly focused on where, since we are interested in measuring the global vibrations on the reactor containment wall, we are focused on evaluation of the measuring point number 1. Here is just another picture, a close-up of measuring point number 1. There you can see a picture where we put in the measuring point number 2. Is on a penetration, and it's just on the inside of the reactor containment there is an open pipe, and on this outside is a locked there's a lock on the piping. So we just put in a sensor in order to have to get a comparable value to see what will be response on measuring on the penetration compared to the actual reactor containment wall. So we use this measuring point for some comparison, but the focus is on the measuring point 1, which on the mounting plate on the reactor containment. And we also put in a third sensor on this hatch, which you can see here. But we will not show any results on that during this presentation. And here is just a picture on the SRV lines, how it looks with insulation and the different separate lines coming down from the steam line. Here we have a picture from the analysis program. To the left, you can see all the measurements that were done, one for each running each test for each individual SRV. And to the right, you can see the possibility in setting up different FFT windows. You can choose how the graphs would look like, and yeah, things like that. And at upper part, you can see the time signal, and below you can see the frequency spectrum of the same signal. If you look into detail for one signal, here is at the measurement at 100%, 69 bar. When we opened VA3, measuring point number 1 in the radial direction, and this is the total time signal for 12 seconds. So when Kent was he was sort of initiating the each test. So he gave the signal to the control room, and then they opened each of the valves, and then the measurements were running for something like 12 seconds. And then the control room made a evaluation to see that the response time of each test were okay. And then we went to the next valve. So this is a general how the time signal looked for each valve opening. And here is the corresponding FFT for the same occasion, the same valve opening, and the same direction. Here we can see that around 20 Hertz we have the highest response, and also some high peaks at 27, 28, some around 10 Hertz. But it seems like the highest response is around 20 Hertz. And if we do a peak-to-peak from, if you look at the frequency from 0 to 200 Hertz, we get a amplitude of 0.95 if you look on the 0 to 200, and if you look on 0 to 500, we have a response on 0.014 Gs. So it's not that high responses in the system during the valve openings. Here we have just showed a picture on when Westinghouse did the evaluation. They did another picture which made it a bit easier to show the location of the vibration of the measuring point compared to the valves. One difference is that they have 90 degrees upwards. So you see the valves from VB1 down to VA2 on the right side. And that the measuring point is located between VD1 and VD3. And here are some results. Here we compare between measuring point number 1, which is at the mounting plate, and measuring point number 2, which is at the penetration. And to the left, we have the 16 different valves and their placement in degrees around the reactor containment. And for each measuring point, we will measure in 3 directions: radial, tangential, and vertical direction. And to the right, you can see a comparison between measuring point 2 and measuring point 1. So you can see the ratio between them. And we can see quite clear that the vibration response at the penetration pipe is considerably higher than at the mounting plate. And of course, that should be what one can expect, since that is you can have larger movement in that one, since it's not that stiff and heavy as the actual reactor containment wall. So, but this is just to see that yeah, we have different results and higher results at the penetration pipe, but we are mostly focused on the mounting plate. And here is just to visualize it, the ratio between the 2 different measuring points in the different directions. If we go to the next one, here we see a peak-to-peak values and a comparison between measuring number 1, which was when we went down with the station, 100% and 69 bar, compared to measurement number 2, which was around 5% and 60 bars. Of course, there are some individual different, but for some occasion we have higher response for the 100% case, and for other we have higher response at the other measurement. So we cannot see a clear distinguished difference between those 2 measurements, and therefore, since we are supposed to doing a follow-up measurement during this outage when we're running up, we decided to just focus on to measure when we'll go up with the station. So that is what we're planning to do today. So we don't do we didn't do the measurement when we went down, since the results are quite comparable. We focused on measuring from one occasion, and that is what hopefully Kent is performing today, so we can have new results to compare with this that were done last year. Here we did a comparison with vibration velocity. We processed the accelerometer, the acceleration results into vibration velocity, RMS, and compared to the normal allowable 8 millimeters per second, which we normally use for allowable vibration measurements. And here to the right, the 3 column to the right is the allowable 8 millimeters divided by the measured vibration velocity. And we can see a very high ratio between the allowable and the measured, indicating that there is a large margin between what we measured compared to what is allowed. Yes. And here we have used measured accelerations and calculated response spectrum with different dampings. And yeah, There is a variation between the measuring point, but you cannot see any clear difference between that. One thing that I can mention, you see on the measuring point closest, when we tested the SRV closest to the measuring point, when we run the test with VD1, VD3, and VD4, we didn't get any results. I discussed with Kent on that yesterday, and he said we're not 100% sure, but they thought that there will be an offset and too high value to say. When we did a test on the valve closest to the measuring point, the sensors were not able to capture that. So during the test that we performed today, we will use the same we will have 3 measurements running. One, same accelerometer at the same location at the mounting plate. Then we will put in a new accelerometer, which are 1/10 sensitivity compared to the one we used last time. And we will also put in one sensor directly on the concrete in order to compare with those also. So in order to get the results for all the valves, we hope that by using another type of sensor which are less sensitive, we hope we can manage to get the results for testing of all of the valves. Yes, here is just in the report that Westinghouse put together. There are a lot of comparison between the measurement done at Forsmark 1 during 1978, but here in the table we just show some results. And if we focus on here it said to the left, inneslutningsväggen, which correspond to the reactor containment wall. You can see that for SRV1, which we are looking for, which is the test that we have performed, we have a value from the test at Forsmark 1 at 0.3 Gs at a frequency of 30 Hertz. And if we go to the column with 0.3 outage 19, we have the corresponding value of 0.2 G and 24 Hertz, which is more or less in the same area as the results from the measurements performed at Forsmark 1 in 78. On the other hand, if you look on the Oskarshamn 3 on the calculations, which are the 4 columns to the right, we can see that for the SRV1, which is the same case as we are looking on, which we had performed the measurements, they have a calculated response of 2.1 Gs at a frequency of 20 Hertz. So the frequency is more or less in the same area, but the values are sort of 10 times higher for the calculations compared to the measurements. So from this we can see that the correspondence between the measurements is quite good between Oskarshamn 3 and Forsmark, and the calculations that we use for the load and then also in the fatigue analysis are much higher than the measured values. Yeah, to sum up the work that has been done, the time history measurements at Oskarshamn 3 is sort of 0.2 G compared to the Forsmark 1, 0.7 G, a bit higher in Oskarshamn, but more or less in the same area. If we look on the response spectra at Oskarshamn 3, as I mentioned, 0.2, and Forsmark 1, 0.3, quite similar. And as we see, also more or less the same frequency area. While the calculations shows loads for Oskarshamn 3 in the area of 2 to 6 Gs, which is considerably higher than the actual measured response on the reactor containment. That gives us that we can conclude that the calculated results are conservative compared to the measured results. and that gives us the margins in the TLA fatigue analysis for those cases where the SRV load is included, that we can say that we have some margins in the analysis, since we have seen that the actual measured loads on the SRV is considerably lower than the calculated response. Okay, thank you very much. That was I had. Are there any questions related to the measurement that we had performed at Oskarshamn 3? Yeah, Ylva, please.
I just wondered, you said you were measuring at 100%. You don't mean full load then?
No,
that's for misunderstanding, because you run 120 something forward.
Yeah. I'm not really sure it was Kent that gave, but as we saw, it doesn't really matter if we have 100% or 50%, since we compared with 69 bars and 60 bars. The actual power level didn't influence the measure response when we did SRV test.
But when you said 100%, you mean a little part load then?
I have to ask Kent if he mean the normal full load, which is 129%, or if we have went down to the 100% load. I'm not sure. We have to ask it. Yep. Elisabeth, I see you have raised your hand.
Normally, they don't want to do low with 129, so it can probably be 100%, not 129. Open my case. So it's probably 100% if he have written that.
Okay, 100%. It could have been 129, but we choose to measure that 100% of. Yep. Okay. Yep. Thank you. We have time for one more question, definitely.
Tobias, it's John Lawrenson here. May I ask a question?
Yes.
What do you think is the main reason that the load is so much higher in the calculations?
Yeah, that is a good question. I mean, as you know, the original calculation, the load calculation, was calibrated compared to experiments performed up in Västerås. But still, we have done the new calculations by Skånskott and so on. We end up more or less in the same results with the analysis. But of course, there are some uncertainties in the analysis, and you put in some conservatives in order to be sure that you're not underestimating any effects. So perhaps, of course, some parts are conservative, but I'm not sure if that can explain a factor of 10 between the measurements and the calculations. I'm not sure.
Maybe we can discuss this during the breakout meeting a little bit more. I also have some comment.
Yep, definitely. Okay, good. Thank you very much. Thank you, especially Thomas, for your presentations. Now we go to the breakout session, where we can discuss in more detail regarding the measurements which we have performed here at Oskarshamn 3. So thank you very much for listening.